In our previous video, we learned how to calculate for the area of a rectangle. Today we're learning how to calculate for the area of a parallelogram. For this video tutorial to be effective, I will be using this format. First, I will flash each question for about 10 seconds, and you may pause the video whenever you want to give yourself time to try out each question. And finally, I will explain each question and I'll give you some tips and strategies on how to solve each question. Are you ready? Here we go. In our previous video, we learned that a trapezoid has only one pair of parallel sides. If a quadrilateral has two pairs of parallel sides, then this quadrilateral now is called a parallelogram. The two parallel sides are called the bases of a parallelogram. On the other hand, the height is the shortest distance between the bases of a parallelogram. In solving for the area of a parallelogram, also remember that the height can be inside or outside the parallelogram. The formula for the area of a parallelogram is the same thing as the formula in finding the area of a rectangle. Area is equal to base times the height. The reason for that is if we're going to cut out this triangle on the left and move it to the right, then the new shape becomes now a rectangle with the same length of base and the same length of height. So the formula for the area of a rectangle and parallelogram is the same. Area is equal to base times height. Question number 1. Find the area of the parallelogram on the right. The formula for the area of a parallelogram is base times height. And in this parallelogram, the base is 9 meters and the height is 6 meters. So when you multiply 9 times 6, that's 54. And the unit for the area is square units. So the area for this parallelogram is 54 square meters. Question number 2. Find the area of the parallelogram below. So using the formula for the area of a parallelogram, that's base times height. In this parallelogram, the base is 11 millimeters and the height is 7 millimeters. So when we multiply 11 times 7, that's 77, and the unit now is millimeter square. So the area of this parallelogram is 77 square millimeters. Question number 3. Find the area of the parallelogram below. In this parallelogram, the base is 14 feet from this point to the right, and the height is also 14 feet, which is outside the parallelogram. So area is, again, using base times height. So we have 14 feet times 14 feet. So 14 times 14 is 196. So the area is 196 square feet. Question number 4. Find the height of the parallelogram given that its area is 78 square feet. So here you were asked to find the height, and the area is given and the base is also given. So using the formula area is equal to base times height, we need to plug in the area, which is 78 square feet. The base is 12 and the height is unknown. So now solving for the height, we can divide both sides by 12. Simplifying this, 12 divided by 12 is 1, so the right side is h. 12 can go into 78 6 times, and the remainder is 6. So we have 6 and 6 twelfths, or that is the same thing as 6.5. So the height is 6.5 feet. Question number 5. Find the length of the height h. Using the formula area is equal to base times height, we can plug in now the given. The area is 72 inches square, base is 12 inches, and the height is unknown. So now solving for the height, we can divide both sides by 12. 72 divided by 12 is 6. 12 divided by 12 is 1. So the right side is just h. So the measurement of the height is 6 inches. Question number 6. Find the length of base B. Using area is equal to base times height, the area is 30 meters square, base is missing, and the height is 5 meters. So now solving for the base, we can divide both sides by 5. 30 divided by 5 is 6. The right side now, 5 divided by 5 is 1, so we have 1b. So the base now here is 6 meters. Question number 7. Find the area of the figure below. Without using any formula for this figure, if we cut this triangle on the left and then move it to the right, then we can see that that will be now a square, 3 units on each side. So the area for this will be 9 units square. Also, this is a parallelogram. So you can also use the formula base times height. And the base here is 3 units. The height is also 3 units. So that means the area for this parallelogram is 9 units square. Question number 8. Find the area of the figure below. This figure has a base of 2 units and a height of 3 units. So the area for this parallelogram is 2 units multiplied by 3 units, which is 6 units square. For question number 9, we have a complex figure combining the area of a rectangle and the area of a parallelogram. So the area for the rectangle using base times height is the same thing as 9 feet times 5 feet, which is 45 square feet. Now we need to add the area of the parallelogram. For the area of the parallelogram, it's also the same thing as base times height. And in this parallelogram above, the base is also 9 feet, but the height is not 5, but the height is 4 feet. So the area for the parallelogram above is 36 square feet. This means the total area for this figure is adding the 45 and 36, which is 81 square feet, which is the total area of this complex figure. For this problem, one way to calculate the total area is calculate first the area of the triangle on the left, and you need to add the area of the parallelogram below. So the area of a triangle on the left can be solved using base times height divided by 2, which is the base is 3 and the height is 13. Divide by 2. So 3 times 13 is 39, and 39 divided by 2 is 19.5. So the area of the triangle below is 19.5 centimeters square. Now we need to get the area of the parallelogram on the right, and using the formula base times height. The base is 12 centimeters and the height is 13 centimeters. So the area for this is 156. So we have 156 centimeters square. And the total area of this complex figure is the sum of 19.5 and 156, which is 175.5 centimeters square. Here are the answers.